In a video I made mid-2005, I looked at the ZNC C compiler for the Spectrum Next. I showed how to set it up and get some code examples running. In this video I thought I'd take C a step further and try and get a random C game source compiled and running on the Next. I searched on the web for a random game, and the first game that came up was the old favourite Snake. I looked through the code, it looked pretty straightforward, and I thought I had a chance of getting it running, even though I never did much C in the past. The game came from the geeksforgeeks.org website. I'll leave a link below. The code was just over 200 lines long and wasn't going to be a very polished version, but it was enough to learn a bit more about C with the Next. I'll look through the code in a minute, but there is a setup function, a draw function, input, the game logic, and the main function. ZNC had been mentioned in one of the Kickstarter 3 videos, which is why I'd looked at it. The ZNC compiler is pushed onto the Next, or sometimes C-Spect, and you could compile C there. So I pushed the Snake code to C-Spect and tried to run the .znc command on the snake.c source file. I got an error on line 3 with the first include statement. Maybe this wasn't going to be too easy. I went on to ChatGPT and asked it about includes in ZNC. The answer wasn't promising. It said the standard library was minimal and I might not be able to get the includes to compile in ZNC. Not a great start. So looking further into C compilers that would work with the Next, there's another C compiler called Z88DK, which has been around since the 90s. It supports many target machines, both the Spectrum and the Next, and also interesting to me, the ZX81. Looking at the Z88DK GitHub page, there were several builds of Z88DK to choose from. These include binary only, full source to build yourself, or nightly builds of the latest code. What I wanted was a version that supported the Spectrum and the Next, and it looked like version 2.4 would do the job. I downloaded the source and unzipped it onto my drive. Initially I tried to use my D drive, but there were some issues, so I moved it onto the C drive. I got a virus warning as I unzipped, possibly a false positive, but difficult to say. The file was quarantined anyhow. To check I got the correct version, I looked in the source on my C and saw the targets for the Sinclair machines. ZX81, Z80, etc. were there. In the bin files were the tools executables. To get the compiler to run on my Windows machine, it doesn't run on the actual Next. I had to set up my Windows path to point to the binary folder, cz88dk/bin, and also set up a system variable, z88dk_home, as shown. I was able to run 2 echo statements in the command line to check that they were set up correctly, one for the path and the other for the system variable. Now I could run zcc-v to see the compiler was working, getting version information. The next thing was to try a Hello World example before moving on to the Snake game. This was just a few lines of code with an include and a cprintf statement to output Hello World. So demoing a Hello World program and then onto the Snake program. So I've got several windows open. In the bottom left I've got the hello.c and snake.c. In the top left I've got a commands.txt file, which is the commands to run on the command line to do the compilation. So I've got 3 for hello for the ZX81, ZX Spectrum and Next, and then same for the Snake. Then in the top right I've got the source for the hello C program. So that uses con.io.h and clears the screen, writes to the screen, and then there's a while loop just to stop the program crashing out. And then I've got my command line window where I'm going to put the commands. So first of all I'll compile the hello C code by copying that into the command line window, and you can see that down in the bottom left that the hello tap has been created for the Spectrum version, and then I'll do the same for the Next version, which is the plus ZXN. So running that, I've now got hello.nex in my folder down the bottom left, and then finally I'll do the same for the ZX81 version. and then that creates hello.p down in the bottom left. So I've got all three executables that I can run, ZX Spectrum, Next and ZX81. And then I've got a put batch file down the bottom right, so that copies any tap files and any Next files into the folder C, for the language C rather than C drive, in my C spec image. So if I run that put, that's run the copy. It also copies up the C as well. And then if I open up C spec, I can see I've got the hello.tap, the hello.nex and the C files. So to run the hello.tap, it simply outputs the hello Spectrum Next, and then going back in, running the hello.nex does the same thing. So, but that's running a Next file rather than a Spectrum file. So then going on to the Snake program, it's about 200 lines long. It's got 5 includes at the top, then some variables at the top of the file. Then I've got a setup function, and then the draw, which draws the whole game field, does the whole thing each time, which is kind of slow. Then input reads what the keyboard, what's been put in the keyboard, and then the logic to control what's going on when you're running the game, and then the main function, which does the whole loop until the game is over. So a draw, input, logic, and then a delay loop at the end. I swapped out the sleep statement because that didn't seem to work. So then compiling the Snake program, I copy the command across for the Spectrum version, and then down in the bottom left you can see it's created my snake.tap file. Then doing the same for the Next version, run that command, and now I've got my, down at the bottom I've got the snake.nex file. And then for the ZX81 version, I did modify the file a little bit to change the height and width, which didn't fit on the screen for the ZX81. And then I've changed the clear screen function. But other than that, I think it's pretty much the same. So copying the ZX81 command and running that. So that's on Snake81. And then if I look down in my file window, I've got snake81.p down at the bottom. So that's all binary, which you can see there now. And then running the put statement, that puts the taps and the NEX. So I've now got my snake.tap, which I can run, and choosing 48K mode, and then it draws the screen, and as you can see it refreshes the whole screen each time, which is quite slow. But the snakes, I'm using the up key, and the snake's moving towards the pill, the star. So the snake is made up of O's. Then each time I pick up a pill, the length of the snake grows. So now it's 2 characters long. Down at the bottom there's a score, which is a bit difficult to see, and it tells you which keys to use. So W, A, S and D. So the snake's now 3 characters long. So that's what the game looks like running on the Spectrum version. And then going back in and running the Next version, you can see it's a lot faster now. So this is more playable really. The snake's already up to 3 characters and heading down for that pill down at the bottom, and now up to 4 characters. So that's the Next version. So now going on to the ZX81 version, so running the hello.p file, it outputs hello Spectrum Next. Capitalization is a bit different, and then running the snake81.p loads that up, and it's drawing it out, and this is the slowest version by far. You can see that I'm moving the snake across to the left now. The screen's a bit different. It's got like blank lines in, which is a bug, which probably won't take too much effort to get out. But that's the snake game running in on the ZX81. So looking at the sizes of the files, the snake.tap is 5 kilobytes. The snake NEX is 16.5 kilobytes, quite a bit bigger. And then the ZX81 version is 5.3 kilobytes. So that's the most critical one, as you've only got the 16K of the ZX81. The game was super basic, but it worked on all 3 platforms, and I was able to move around the playing area using the keys and grow the snake by picking up the pills. As a cprintf statement converts to code that runs slowly in the ZX81, to make the game run faster there, it would be necessary to replace this with a routine that wrote directly to the ZX81 screen RAM, but that shouldn't be too difficult. So that's getting a random C game off the web to run on the next Spectrum and ZX81. Hope that was interesting, and I might take this further in later videos. Thanks for watching.